Hi, welcome to the Introstat lecture series. And this video, we're going to take a look at the midterm exam number 2 review. And we're going to have 2 videos for this exam number 2 review. So we won't have a long video just for one. So, all right. So now let's go ahead and take a look at our exam, midterm exam number 2 here. Let's see what type of problems we have. Okay. So let's go ahead and get started here. Okay, so a survey. Okay, let me get my pencils out here. All right. So a survey of auto park in the student and staff lots inside the garage, parking garage at a very large university. Is classified by the brands of the countries of origin as seen in the tables here. Okay, so now the questions here say, you saw a European car driving out of the parking garage. What is the probability that this car was parked in the student parking garage? The student side of the garage is here. Okay, so here, take a look here. So you see a European car come out, right? So here, this part is the European car. So total, how many cars here we have? We have 45, right? So we have 45 cars, the European car. And then you want to find in this unit 45, what is the probability? And this car is parking at the student parking lot. So we know in the student parking lot, we have 33, right? So what is the probability here? Will be 33 over what? 33 over 45 here. So if you do the 33 over 45, and you will get about the 73% here. Okay. All right, so it's about 73%. If you put into the calculator, you will get it 0.7333 something, right? So I know my answers here will be the B's. Here's 73%. All right, let's take a look at the next questions here. The next question tells you for a highly right-skewed distribution, what is the relation between the values of the mean and the median? We know the highly right skews, right? So here, the right skew. So when we say the left skew or right skew, is where is the tails here. So if right skew, that means on the right-hand side of the distribution, I have what? I have a tails here. So right skew will be some distribution look like this. Okay, so if you have some distribution look like this, so I know you go further here, this is the largest numbers, right? Okay, so we know what is the mean. Mean is your average, all this value. Because I have a lot of those, I have more those larger number. So what happens here? So mean going to be influenced by those large number. So mean going to be dragged over a little bit to the right-hand side. And then the medians here, the median, just the middle one, this doesn't matter. You have a large value, small value. So here will be the medians here. Right? So it's because of because the right tail, right? It's a right skew. That means you have a right tail. And those right tail is the larger number. And the mean is you add all those numbers and then divide by how many, right? So those large number will what? Will influence the means here. All right, so what will be our answers here? So we said the mean going to be what? Mean going to be greater than what? Greater than medians here. All right, okay. So now let's take a look at the problem number 3. This is a contingency table questions again. So let's say a company held a blood pressure screening clinic for its employees. The results are summarized here by age group, by the blood pressure, low, medium, or high. And so in here, let's say you met an employee for this company. What is the probability that this employee is the middle-aged worker with a high blood pressure. Okay, so you met employees. That means if you add the totals here, so you add all this 9, so total, if you add all these 9 numbers here, 27, 37, 31, 48, 91, what you will have here, you will have 474 here. Okay, then it asks you, so let's say, what is the probability this employee will be a middle-aged worker with a high blood pressure? Middle-aged worker is 30 to 49, the high blood pressure. Which part is this one? This one's here. So it's 51 here, right? So what is the probabilities here? So it will be the 51 out of what? 474, right? So if you use the calculator, 51 divided by 474, what you will have here? 0.08, so this will be 0.0865, something like that, right? Okay, so now, so it's a 51 over, did I calculate it right? Oh, I did not have 51 divided by 474. Yes, oh, okay, so yeah, I put it in the calculator wrong. So this number going to be 0.1076 here, right? So that means it's 10.79, 10.76%. So what is the closest ones here? Is about the 11%, right? So let's so the answer will be B here. All right. Okay, so now let's take a look at the number 4 here. It said it has been reported that a large city, the average price gallon regular gas is 3.59. Residents believe this is different from here, right? So here, this is our keyword is different. Then to test this claim, data is gathered from the 36 gas station. The mean value, the mean price is 3.65. That means out of this 36 gas station, I have the average is 3.65. And then they said, assume the population standard deviation is 0.6 to 0.25. I want to test the claim at the 10% level. So what type of the test we should do? All right. So here, this is the, so 3.65, this is X bars, right? And then what is here? This is a population 0.25. So I know the 0.25 is what type of the parameter? This is the sigma. So this is the population sigmas, right? So for the population sigma, this one is what? This is known. So this will be, if it's sigma is known, then what type of the test I'm having here? I'm having what? Z test, right? So the answer will be the Z test here, right? So because we said the test for the means, right? So basically we are testing for the mean. So basically because here you will say your test mu is equal to 3.59, then your alternative hypothesis mu is not equal to the 3.59, right? So we have two tests. We can either use the Z or T, right? So we said Z is for the population sigma, is given or is known. So this one is a Z test. All right, let's take a look at the number 5. All right, so we said which of the following is true about the student T models here. So first ones here, let's take a look here. They are unimodal, symmetric, and bear-shaped. Is this true? Yes. We say it's very similar to the normal distribution. Then the second ones here, we said they have a light tail than the normal distribution. Is this true? No. We know what? We know if this is normal, right? If this is normal, then the T distribution has a what? Have a heavier tails, right? So the light tail So the light tells here, this is not true, right? So it's a t distribution have a heavier tails here. All right. So the next one's here, they say, as the degrees of freedom increase, the T model looks more and more like a normal distribution. That is correct. Because we know that when we said when the the degrees of freedom increase to the infinity, the T distribution will become normal distribution. Even we don't really need infinity. We said that when the degrees of freedom typical is greater than 30, then the T model will look very similar like the normal model. Okay, and so the last number D is here. Let's say T model is used to test the population mean when the population sigma is not known. That's correct, right? So we use the T model. So we use the Z model is when the population sigma is known. All right, so now next one see here. Okay, so the next one we said we want to find what is the value of the Z0. So when we do this kind of problem, what do we do here? We typical, if you can draw a picture, that would be better. So this is a standard Z, I have zeros here. Then you have 1.05. And you have some Z zeros here. That's what we want to find. Then it tell you, let's say, hey, here, between these ones here. So let's say this area, right? So this yellow area is A3, A5. Okay, so this area, this is pointer A3, A5. And I want to find a Z0. We know if I want to find a Z0, I can use the inverse norm. But the inverse norm, the area you need to input is all the way to the left, right? So the first thing is I need to find out these pink areas here. Right, so I need to find out this pink area. So for these pink areas, then I need to add the pink area and the yellow area together. So let's go to my calculator. So let me leave here. Then let's do a screen share for my calculator here. All right. Okay, so here, let's take a look here. Remember, how do we do it, right? Okay, so the first I need to find the pink area we just did. So what do we did here? So we say second distribution. We know the normal CDF. So the pink area is all the way to the left. So it's the lower bound is the default. So what is the up bound is a negative 1.05. We say in the TI-84, the negative, be very careful. You cannot just type in the negative here. So you need to use this parenthesis. So you say negative 1.05. All right, now here, there you go. So what is going to give you 0.14684? Okay, now let's go back to our practice here. So now we see here, so we just get it. So this area, this pink area is 0.14684. So if you add it together, that will be the whole, everything to the left, right? So it's 0.14684 plus 0.8385. So what is going to be? So this will be 0.98535. Okay, now I can use the inverse norm. So let's go to my calculator again. So here is my calculator. Okay, let's clear this. I want to find the Z0. So I go to the second distribution. Then I go to the inverse norm here. So you said the inverse norm. Remember, it's the area all the way to the left, right? So it's 0.98535. All right, 0.98535. Then you go all the way down. So what is it going to give you? 2.1794. Okay, so it's 2.1794. Let's go back to here. Okay, so we find out Z0 is 2.1794. So which one is the closest ones here? Is 2.18. So the answer is A. Okay, number 7. So we say for a sample n equal to 25, and the significance level is alpha equal to the 0.05. These ones, they ask, what is the differences between the Z critical value and the T critical value? So what I want to find is the Z critical value minus T critical values here. Okay, so here, let's take a look. Right? So this is the sample, the significance is alpha equal to the 0.05, and I am going to test the one tail test, the right tail. All right, so let's try to do a graph here first. So I'm doing the one tail, right? So one tail, the right tail is this tails, right? So this is the tail. And we know the alpha equal to the 0.05. Well, let me do a bigger ones here. Maybe it's easy to see. Right, so right tail is here. Okay, so here, this one, let's see here, this is my right tail, right? So that's the right tail, and the significance level, this is a 0.05. So in order to find, so you can find is the Z-score or the T-scores, right? So let's use the calculator, but it doesn't matter, either Z or T, the calculated input need to be what is all the way to the what? All the way to the left, right? So all this left area. So this left area, so this is a 0.05. So what is this left area? Will be what? The green area, so it's 0.95. See here. Okay, so now let's go back to the my calculators here. Okay, so remember, all right, so clear that out. Okay, let's take a look at the Z critical. Second, this bars. If you find the Z, I need to use the inverse norm. Remember the green area is what we need to input, right? So it's 0.95. Then here, so what you have here is 1.64485, right? Okay, now this is a 1.64485. All right, so now let's take a look at the T distributions, right? So T critical. Okay, clear that out. So I said the second bars T, I need to use what? Inverse T's here. So still you input the green area, so it's 0.95. Then the degrees freedom, remember you test the degrees freedom is n minus 1 here. So the n is 25, so it's 24. Okay, so let's see here, what do we have here? So we have 1.710, 1.71088. Okay, all right, so now let's go back to my, so we have the Z is equal to the 1.64485, T is equal to the 1.71088. So they want to find the differences. So it will just be 1.64485 minus 1.71088. So what I have here, I have negative 0.066. So for rounding, so what will be my answer choice here? So will be part D here. Okay, let's take a look. All right, so let's see number 8 here. We learn from our lab, we know how to do the box plot, right? So the box plot here, let's say what is the main advantage of using the box plot? So like we talk about during our office hour, we said the main advantage, box plot is not too easy to construct, especially if you don't have a software. If you have a huge data set without a software, probably it's not easy, but it's okay. With the software, it's okay. So Then in here, we say easy to compare the distribution among the different group. And we know this is my main advantages here. Because like, remember we talked about, we said for the box plot, you can put a lot of them in a similar graph, right? So like in here, then you'll be able to compare several groups in one single graph. That's why, that's the main advantage, is to compare. So C, let's say, show 50% of the data inside the box. This is a true statement, right? So this is a true statement, but that is not the main advantages here. Also, the part D here, they show the whisker. Those are the whiskers, right? So those are the whisker. So the whisker can show distribution variation. This is also a true statement as well. All right. So this is also the true statement, but that's not the main advantages here. Okay, so let's say use only Q1, Q2, Q3 statistics. Then we use the maxima, minima also. So that's why the best one, the main advantage is easy to compare. Okay, number 9. So which of the following is not an assumption or condition to check one sample t-test? So we know the randomization is the one of the main, is the assumption we need to follow. 10% near normal independent. So in here, success or fail condition, that's not the one thing we check for the one sample t-test here. Okay. Number 10. Okay, so here is what is the probability? What is the probability between the 0.2 for the given score? So this one will be pretty straightforward, right? So you graph the normal distribution. Now here, this is the 0.2, and this is 2.33, and you are looking for the distributions. You are looking for this yellow area to see what is the probabilities here. Okay, now let's go ahead, take a look my calculators here. So for my calculator, let's clear that out. So what do we need to do? We say second bars. Then I use the CDF, right? So the lower limit is 0.2 and the upper limit is 2.33. Okay, so now we just go down here and we will get a 0.41. So 41084. So we will get this yellow area is 0.41084. Okay, so let's go back to our reviews here. Okay, so that's why it's 0.41084. So what is the closest answer? So it's this here. Okay, so all right, so now in here, let's take a look here. So they said they use the data set, construct a conditional contingency table as showing in here. All right, so like I want to show the contingency table is here with variable is race group as the marginal distributions here. So as the, it's variable as the, so here, be careful, here, that's the race group is the conditional distribution. And then I want to as the marginal distribution, which of the following is the correct coding here. So this is the one, all right? So when I talk about the conditional contingency table, conditional, that means what is under the race groups here, right? So like if you, so answer for here, the code here, the correct answer is part D here. So you'd be careful. You know, if you put it up, depends on which one you put it first, right? So here you say sex here, and then in here you say the race group. So the first variable you put here, it will be your colors here. Okay, then the second ones here you put over here, that will be your races here. Okay, so if you put it like this, and then that means so if you see here, when we talk about the conditional, that means under each race is here. So for example, like the males here, this will be 26.54%, because I'm using the percents, right? And the females here is 73.5445. Okay, so 46 here. That means when you add this one, it's always 100%. So if you find the distribution for the Hispanic, this is 100%. And so white is 100%, 100%. That is what we mix, you know, like the race group is here. So the D, so E is here because you don't have the percentages here. All right. And so that will just give you the, you know, if you use the E, it will just give you total how many under each here. Okay. And so if you use the C, if the race group is in the front, so then your contingency table will look like here. So this is the black, this is a Hispanic, and this is the other, and this is white. Then here will be what? This will be male and the female. So it's kind of, so be careful, right? So the first variables here is the colors here. All right, let's take a look at number 12 here. All right, so the number 12 tell you, assuming the sample was taken from the normal population, which type of the performed the test? Okay, so let's take a look here. So we are testing, so the meals, right? We are testing the meal, the sample statistic. The average is 0.40871. And here, this is the sigma equal to the 9200. Okay, so this is one sample test for me. But what is this one here? This is the population sigma. So it's known, right? So we know it's known, or sometimes we say it's given. If it's given or known, so what do we mean here? That means we use the z-test here, right? All right, so that's why we put the z-test here. Okay, let's take a look at number 13 here. The number 13, they said, is the partial, you know, the following contingency table showing the male and the female student for the 100 high school students here, and how many of them is right-handed, how many is left-handed here. Okay, so here they say if there's no association between the genders and the handedness here. So when it means no association, that means you know, this is the gender and the right hand, left hand should be independent, right? So they shouldn't have any kind of the, so if I say it's 60% for the people are right-handed and 40% are left-handed, then the male and the female, they should be around these ranges here, right? So like right now in here, you say the male, right-handed male is 32 out of the 40. So I know the 32 out of the 40 here. So let's see here, 32 out of the 40 is a what? It's a 0.8. Or you can say it's 80%, right? So that means the male, the right-handed is 80%. If the right-handed, left-handed has nothing to do with the sex, the genders, right? So that means female should be around 80% also. right? Because that means in general, the whole population is 80% is right-handed. So now for the female have 60. So how many we have right-handed will be 60 times the 0.8. So we should have a 48 here. Okay, so that's why in here we say, okay, so the answer is 48, right? So be very careful here. That means no association. No association, that means, you know, these two variables should be kind of the independent. You know, if in general we have 80% of right-handed, so this should be equal to male and the females, right? So it doesn't matter, right? So that means there's no association. So gender will not affect your right-handed or left-handed. Yeah. All right, okay. Now let's take a look at number 14 here. So they say fuel economic estimate automobile built 1 year predict the mean is 25.8 mile per gallon. And the standard deviation is 2.3 mile per gallon for highway. What is the gas mileage worth 2.5% of the car? Okay, so let's take a look here. Let's draw pictures here. All right. So here in general, the mean is 25.8. Then they want to see the worst 2.5%. Worst, that means it's less gas mileage, right? So that means here they want to see the worst 2.5%. So this yellow area is what? 0.025, right? So I want to find what is this value will give me the worst 2.5%. Okay, now let's go to my calculator. Let's do again, do the calculator. All right, so I'm finding similar, like I'm finding the z-score. So which function I'm going to use? I'm going to use what? Inverse norm here, right? Okay, so what is the area? Area is the area to the left. So it's that yellow area, so it's 0.025. Now my mean is what? It's 25.8. And what is the standard deviation? It's 2.3. Okay, now let's see what do we have here. So I have a 21.29. Okay, now let's go back to our test here. So this one's here. So this one's here from, we have 21.29. So what is our solutions here? That means if it's less than matter, right? So that means they get less than 21.2 or they get more than 21.2. So what is here? They will get less than 21.2, right? Okay, so that's why the boundaries here, this value here is 21.29 here. Okay, now let's take a look at number 15. So we said two companies make the new batteries targeted at owners of a personal music player. Brand A claim a mean battery is 12 hours, and while brand B is 15 hours. All right. So suppose the standard deviation is 1.5 for A and 3 for B here. So you are heading for 9 hours at the beach, and which battery is most likely to last 7 hours here? All right, so basically here, this is your A. And what is the A's here? Mean is 12, right? So they want to last for 7 hours. So that means you want to find this yellow area. And then for B's here is what? And this one's here, B is 15 hours. And you want to find more than 7. So that means I'm going to find this light pink area for B's here. Okay, now This one's here. Let's go to the calculator. Okay, so let's take a look at A. Here, clear. So it's a second bars, and I'm going to find the normal CDF, right? So I'm going to greater than 7. So I need to put a 7 here. Then what is my upper bound? Upper bound to the infinities, right? So I just put a 9. And then what is my mean? Is 12. Okay. And what is my standard deviation? 1.5 here. Okay. So now let's see what do we have. So we have a 0.99957. So we know this, we know the yellow one is 0.99957. Let's take a look at my battery B. So second bars again, so normal CDF. So I have a 7, upper bound still the same, but now my mean changed to what? 15. Now what is my standard deviation? 3. Okay. So I get a 9961695. So my pink area is a pointer 9961695. Okay, so let's go back to the exams here. So I know that the battery A is 99957, battery B is 9961. So which one is the last have the is more likely? Is the what is the brand A's batteries, right? It's more likely last 7 hours has the higher probabilities here. Okay, so now, okay, so the last one for this video, so maybe we do the till the 17th here, okay? So this one's here, they said that if alpha, is 0.01 for 2 tails, okay, be careful for 2 tails, hypothesis testing with n equal to 10. So what is the critical values here? Okay, so let's graph it. So here, 2 tail, that means both tails, right? So both tails, so that means this area and this area here. All right. And so when you add both areas, 0.01. So what happened to each area? This is 0.005, and this is 0.0. So this will be 0.005 here. So I need to find that this is one of my critical values. This is one of my critical values here. Okay. So let's take a look at my calculator here. Okay, so clear. So now I'm going to second bars. Now I need to use the inverse t's here, right? So the area is to the left. So the first one is 0.005. So what is the degrees freedom? And -1, so it's 9. So here, let's see here. I got a negative 3.25. Okay, so this one's here. This is negative 3.25. Okay, so now I am going to, so we got a here, right? So we got a negative 3.25. Now I'm going to find this one here, right? Remember, if I want to use the inverse normal, which area I need to find? I need to find all the way to the left, right? All the way to the left. So right now, the tail area is 0.005. So this light pink is what? 0.995. Okay, so now let's go to the calculator. So let's do again. So it's the second bars. So it's inverse t. So it's point, right now it's 0.995, right? So the degrees freedom is still the same. So what do I have here? I got a 3.24. Okay, that is, so here this is 3.25. So I have two critical values because I have a true tail. So where is my answers here? It's plus minus the what? 3.25. So I have 2. Okay, so last problem for this video here. So these ones here, they say, what will be the best chart to graph the data of a contingency table? Easy to see there is any association between the two variables here. So if they are contingency tables, right? So we know the contingency table is something like this. So you have, this is a variable number 1, variable number 2 here, right? So what is the chart is the best to compare? So the answers here is a segmented bar chart. What is the segmented bar chart here? So for example, this contingency table here. So if you put a variable 1, we have a category, let's say here's A, B, C, D, right? So this is a variable number 1. So what is the segmented bar chart? That means they all going to become to the 100%. So they will have like a bar like this for the 4 numbers here, variable number 1. Okay, then for the variable number 2 here, I could have the different values here, right? So variable number 2, say X and Y, so whatever, right? So X, Y values here. So now, what is the segment bar chart? So they all reach to the 100%. So like in here, so if I say this one here is this way, this way, this way, and this way, see here, right? So then for the, so this is the 1 variable, 1 variable, 1 variable. So this is, for example, is the X value for the 1 variable. Then the top here, when they add it together, they're all going to be 100%, right? So this is the top here. Okay, so then it's very easy to see, you know, like for here, you say variable 1, it does acting differently with variable 2, right? Because these ones here, the pink and the yellow is the variable 2's value. So you see here, the variable 1, if I have 4 values, like see here, like it's A, B, C, D's, right? So if I have A, B, C, D, then the variable 2 have X, Y. So I know, you know, for variable 1, if variable 1 is A, then I will have more Y than X here. So this is what we call this a segmented bar chart. The segmented bar chart is typical, is another way try to represent the contingency tables here. We know the box chart is none, right? The box chart is, this is for continuous type of the data, right? That's why it's this type of the data. You need to have the readings, right? The continuous type of data. Bar chart and histogram is the same. They are good for 1 variable, right? And the stem and the leaf chart, this is also is kind of like this is for the quantitative type of the variable. It's not for the categorical. For the categorical type of the point, you know, the good chart for the true variable will be the segmented bar chart here. All right, that's it. And let's take a break and then we'll come back to finish the remaining of this test review. Okay, talk to you later. Okay, bye-bye.